Hello everyone, welcome to my channel. So today I'm gonna run a couple of tests and show few methods of using some electric power, and also I will try to show how to harvest some power from the sea of energy where we are living. Yeah, so for the beginning I'm gonna show the voltage of batteries for start. This is after 16 hours rest after charging. This is the resting voltage. Yeah, one. And now the second group. Okay, now because the circuit doesn't work with a voltage less than 16 volts, we're gonna put them in parallel, in series. Yeah, we have a parallel bank, another parallel bank, so place them in series. That is gonna give us, let's see, yeah, always like that when you want to show something. Just don't wanna sit. One, yeah, 3635. This is our start voltage. Okay, now we're gonna set current. We go for 20 amps. I know I'm gonna draw a lot of power. Yeah, DC set to 0. Okay, now I'm gonna show the whole system. Yeah, MCB, ZVS driver, cheap one, very cheap one. Yeah, as you observe here, input voltage accepted. There's the pancake arrangement. We have 1, 2, 3, 4, 5 coils. First coil on the bottom it's bifilar anti-parallel connected. Second coil that couple with it's a bifilar series connected, and connected in series with another 3 monofilar coils. Wire used, it's 1.5 millimeter speaker wire, copper, not aluminium. There are 34 turns in total. Yeah, for bifilar it's going to be 17 audios. Yeah, okay, this is the beginning of the receiver coil. Yeah, and this is the end of the last monofiller. Yeah, this is gonna give us the high voltage, yeah, to drive 9 bulbs in parallel, 10 watts each for the moment. And this is the beginning of the secondary, yeah, beginning of the secondary. I have added a ground. I can take it off for the moment and I will put it back later when I'm gonna show different things. So we have in total 9 bulbs, all the same. Anyway, I showed in a previous video full specification. Let me try here. Okay. This is the 9 bulbs that I'm using. Yeah? Okay. Okay, now let's begin. Flip the switch. We are taking 260 milliamps. To be more precise, to go on a smaller scale, actually it's 260 something, 60, 270, yeah? Okay, I'm going on a big scale now. So, we know now the circuit is working. So, we have no wires, no anything. Yeah, and now we start. 1, yeah, power drone. 1, fully lit in full sun. 2, 3, power drone from batteries. And the last one, we have 3, 6, oops, 9 9 volts in total. Fully lit, no flickering, no anything. Yeah. Okay, let's move on in the shadow. Power drone. Yeah. Now, to make sure we are not going to fool ourselves, we need to observe some voltage sagging under the load. Yeah, we have nearly about 1 volt drop in voltage under 100 watts, 90 watts, sorry, 90 watts of power drawn. Yeah, okay. Now let's see what capabilities we have here. So we're gonna take one out. This is incandescent bulb, 40 watts. Now the camera doesn't capture perfect. I can tell you it's fully lit, looks completely different. It is in full sun. And it's getting hot, very hot. We are drawing 632 amps from batteries. The MCB making a funny noise. It's a cheap MCB, bought from Amazon, Chinese production. It's rated for 10 amps, but I really doubt it can handle more than 5 amps. You can hear the sound, it's coming from the MCB. It's not from ZVS, yeah? Now we're gonna start in full load with no problem. Yeah? All bulbs receive a lot of current, they're getting warm. This one, okay, we're gonna reduce a bit. So we have 40 watts. These LEDs are 10 watts each. So we have 30 watts plus 40 watts. Fully lit, all of them. Yeah. Okay, we have 3.3 amps. Now let's check the voltage. Yeah, this is under 70 watts of power. Yeah, from 26. So we have about 1 volt. Yeah, equivalent. What we had for the other ones. Yeah, so that's pretty correct. From this power we need to take out, I don't know how much it consumes. Empty, we have about 260 milliamps consumption for the whole circuit, but I cannot guarantee what is the total consumption of the circuit, ZVS plus the coils, under the load. So I will assume any loss in power It's going to be part of the whole circuit, including the loads. Yeah, okay. Now let's add one more. If I have one, I should have one. Should have one somewhere. Oh, it's right here. Sorry. So now we have 80 watts power. Yeah, 80 plus another 30, 110. Power consumption from the batteries 5 amps. Yeah, let's increase. So we have 120 watts, 130, 140. MCB start to buzz again. Now we're drawing 7.5 amps. Yeah, let's add one more. So we have 2, 6, 7 bulbs of 10 watts, 70 watts plus another 80. Yeah, 150 watts of power. 8 amps. $24.84. Yeah, 25 by 8 is nearly 200 watts roughly. So it's a little bit too much for the little batteries to draw them like that. It's crazy. Okay, we're gonna take this out. It's hot. Okay, now let's test. One wire transfer, yeah, through the earth. Yeah, so it connect on the high voltage side, yeah, end of the secondary. Earth will be added at the beginning of the secondary. Exactly how is it in Tesla patents? Yeah, you'll see many patents using these bifilar coils. Yeah, okay. Now okay, now let's connect again the circuit so we don't have any power drawn. 2.2 amps, yeah, and 2.2 amps is okay. System empty. Now it shows 300 milliamps, whatever. it draw, yeah, with no load connected. Now we have this, yeah. I'm gonna disconnect the valves, yeah, well, just to avoid any discussions unnecessary, yeah. Earth number 1, earth number 2. Not a great cable, just some scrap that I had available, yeah. Circuit, it's empty with no load, 300 milliamps, yeah. And now we have one wire, power transmission through the earth, 40 watts bulb, incandescent, yeah. Start to warm up. Power drum, 1.1, 1.8 amps, yeah. Okay, just to make sure we get this correct, I'm gonna take this out and use the same bulb as in previous test, yeah, the 10 watts bulb. And there's the power for one bulb LED, yeah. Okay, now we're gonna put this one back. We're gonna add in the same time, so I'm gonna connect yeah, and we need to bring the other one up. Yeah, connected as before. And now let's see, yeah. I don't know, one glows, so this one through the earth glows a little bit less than the other one powered directly by the circuit, yeah. I'm not gonna hide this fact, we are going to lose a little bit of power here, yeah. Even if the distance between the two earths, it's about 2 meters and a half, something like that, yeah. But also notice the wire, it's 0.75, this one it's 1.5 square millimeters, 0.75 millimeters square millimeters wire. Everything else it's 1.5, apart from some bulbs that they don't need on such a short distance more than that. So I'm not sure if it's the ground or just the wire that I used. Now we're gonna start to draw power from both circuits, directly from the circuit, yeah, and indirect, yeah, through the earth, Okay. In the meantime, DC reset to 0. 5:30. Yeah, we have 2, 4, 6, 7, 8. 8 bulbs, 10 watts each, plus another 80. Yeah, and this one, it's through the earth. A little bit less power. Yeah, current draw 8.5 amps. Yeah, 8.5 by 24, 25 volts, whatever. Yeah, so let's say about 200 watts of power drawn direct. Yeah, so pretty efficient for light, not bad. Yeah, okay. Fuck. Okay, now, okay, I'm gonna stop this, and we are going to use something else instead of the earth. Yeah, yeah, okay. We're gonna disconnect, 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 disconnect them all. Okay, everything is disconnected. Power the circuit 2.3. Yeah, whatever, it's never accurate. Yeah, now the circuit is empty. Yeah, I'm gonna keep them on, actually, just for the sake of avoiding stupid questions. I'm gonna disconnect it. And I will reconnect later. Yeah, okay. Now this is architectural sheets, aluminium. Yeah, 2 aluminium foils with a plastic in between. Yeah, they have very good strength. Yeah, and they have a coating, white coating on them. Yeah, I have sanded off the paint for contact. We will see that. This one is the same. I just insulated all the edges to make sure we are not going to let any electric charge to escape from what we capture. Yeah, so the end of the cable sits in between the washer and the aluminium sheet, and it's pretty much fixed with insulation tape. Yeah, okay. Now I'm gonna take take the wire. It's a little bit long, and instead of through the earth, we're gonna have from earth to air, like in Tesla radiant energy apparatus. Yeah? Okay. Yeah. So the bulb is not connected. We are still taking 230 milliamps from the batteries. Yeah. And yeah, with the side connected up into the sun. Okay, now we're gonna connect the 40-watt bulb. Nothing. Yeah. Okay, we're gonna take this out and we're gonna try 10-watt bulb. Yeah, start to flicker. We have a little bit of power. Yeah, disconnected, connected. Yeah. Now it start to stop flickering. It's still lit up. Yeah, you can see it's just a tiny bit. Okay, now I'm gonna touch the yeah, I'm just touching it. Yeah? And we have improved a little bit the connection. Hand off, hand on, hand off, hand on. Okay, now I'm gonna take, I have taken out, yeah, and I'm holding in my hand. You may observe it's a little bit more intense, yeah, and now we're gonna place it face down. The light is much stronger, yeah. So the earth is on the other side, yeah, on the other side, right here, yeah. Straight into the beginning of the secondary, yeah. Goes all the way around and comes out here. Connect the bulb, and the other side of the bulb connects to the wire straight into the plate. Yeah, so whatever we collect from the air, it's very little. Yeah. Well, I have another sheet, probably I will use in the next video. Yeah, it doesn't improve much the collection. Yeah. Okay, let's but it does something. Yeah. And I want to point out, so I just give up trying to rectify. the output through the earth. They are BYV27200 diodes. This is 6A10 diodes. Yeah, they simply melt. So this one can carry 6 amps, 6 amps at 1000 volts. Yeah, they start to melt. That's it. Yeah, okay. Now yeah, the okay, the picture with the blue, it's from rimstar.org, yeah, showing the electric field of the earth, so-called electrostatic field. Yeah, and now look at the insulated wire coming from the ground. Yeah, if it's not insulated, the electric field will look completely different. Yeah, so the conductor coming from the ground must be uninsulated only at the top, just the tip. Yeah, and then observe the shape. Yeah, you have the high voltage 12 kilovolts. Yeah, right there. And now place the tip of the conductor from the ground right into this excellent collector. Yeah, and observe the earth connection. Yeah, you can go and check online. Also, I want to point out the shape of the collector. So it's not tubular, it's not enclosed. This allows a self-discharge when the voltage goes too much high. And this one, it's a very clever way to make it safe. So you don't need additional line from the air, from the collector to the ground, where you need to place gas discharge tube or spark gap or anything else to let the extra voltage to go off instead of destroying the circuit. Yeah, so this one plus this one, yeah, you need a better shape. In no way this one is good for collection. Whatever you insulation measure take is not gonna be good. Yeah, we can observe here all these bubbles. Yeah, they are perfectly described in the patent. Why is that shape? Because they can hold the charge. And doing all the bubbles that you can see here, yeah, you simply increase the surface where the radiation fell off. Yeah, you have a much greater surface by doing this, and allow a safe discharge when you have a very high voltage. Yeah, we can observe the capacitor, it's filled up. Yeah, it's filled up, as you see in the patent, by a generator. it has the role to excite a higher, much higher potential. In my opinion, there is no link between the frequency of this generator. It was an electric generator at that time, not very performant, so I won't expect very high frequency, yeah, but you have a very high potential that it's hammered by the magnetic flux from the generator, and you have a high potential from the ground up in the air to the high voltage. So this is your voltage source, this is your current source, in a single setup, in a single device. You have combined here both of them, current source and voltage source, and it's going to give you all the power that you ever need if you size them correctly. And also observe my surroundings. In no way I will have here available this clarified field that you can see. I have in no way this clarified field which I may employ to capture atmospheric electricity. So if you build such a thing, you need to think that it needs to be placed in open space, somewhere in the field, top of the hill or flat, anywhere. And you need to have nothing around objects that will distort this field. You need to collect here the maximum. And for just a house, to power a house, my estimation, you don't need. Also seen in some different circuits shared online, yeah, you don't need to go higher than 8-9 meters, 12 meters maximum. You don't need to. Electrostatic field of Earth vary from 75 volts per meter up to 300 volts per meter in fair weather. If it's a storm, that will go much higher, yeah. And when you dimension, when you size your inductors, yeah, you need to size them to use voltage with very small current, yeah. This is important. When you design an electromagnet, you can design it for voltage mainly or for current mainly. Most of what we use today, it's based on current, and it's wrong, because we are using voltage source, yeah, voltage source to provide a current. That's why we destroy on purpose all the voltage sources. It's wrong usage. That's all what I have to say, yeah. I may come back with many more details and different setups. I will present this very simple, easy circuit. It's the size of my hand. Well, I don't have a measure tape. Yeah, size of my hand. I don't know, 250 millimeters, 50 in the center, 50 millimeters. So yeah, roughly about 250 millimeters. Yeah, maybe 1, 2, 3, whatever is there. Just few turns, not many. You can count them. You can pause and count them. Both of them, they are bifilar. This is speaker wire. It comes as a bifilar direct, and you wind directly to, yeah. First coil underneath, it is anti-parallel connected, while the receiver coil on the top, it's bifilar series connected as per Tesla patent. Yeah, we use 2 resistors and a pot with MJ 150 15015G transistor, yeah, but it's better to use the classic one, 2N3055. It will be much better, yeah. With this circuit you can draw even 8 amps. I did that with well, I don't have handy, with a 9-volt battery. So from 9-volt battery, consider that measuring 8 volts, I can take out from that battery current of 8 amps, but I have stopped after a few seconds to prevent an explosion of the battery. So you need to be mindful whatever you want to take out, yeah. But this one, it's perfect for any source with limited or very little current available. It will suck any current available and raise the voltage to deliver all what it can from any available source, yeah. So you can use earth battery, water batteries, I don't know, anything that batteries, even even this atmospheric collection, but you need a very good ground, yeah. So this, it's an this one, it's an improvement of this, yeah. And GVS driver allow a very good power transfer. Nothing get hot, nothing, no coils, not the ZVS, only the loads when they receive too much current. That's it. Well, I hope you enjoy. It's already a very long video, a little bit more than I was planned, but I hope you can find some useful information and use it. If you have any questions, I'm happy to answer. Many thanks for watching, and goodbye for the moment.